So hello guys, today we'll be looking at Advent of Code problem 1 walkthrough from the year 2024. It has started from 2015 if you are unfamiliar with this, but I think you can figure that out on this website. It's on adventofcode.com, and this happens in the month of December from day 1 to day 25th. Each problem unlocks like each day of December in an advent calendar fashion. And so that's why I'm recording this in July, and that's why you will be seeing everything unlocked. But during the contest, everything will unlock one day at a time. Without further ado, let's look at the day one problem. So there's a lot of story, and I think you have just read this or something, but I will explain the problem in a minute. Everything is okay. Okay, so the problem we're given is we have like a list with location IDs, which are not in a line, which are actually side by side. So for example, they provide a sample like this left one will be one list, and this right one will be another list. But the initial problem which we might face when we are reading files, we will be reading in lines or the whole file at a time. We will not be reading it like in a row-wise fashion. We will not be reading it in a column-wise fashion. Each lines or rows will be presented to us, not columns. So we need to parse this of each row. We want to take the left one and the right one and store it somewhere to build up these two lists. Next up, they tell us how to actually solve the problem. They tell us by giving us examples is to pair up the smallest number in the left list with the smallest number in the right list. So for the beginning, for these, there will be 1 on the left list will be paired up with the smallest, which is 3. The next smallest in left is 2, and that will be paired up with another 3. We have 3 3s on the right side, which is fine, and so on. And we need to find the difference between these two, and you can subtract any of these and get the absolute value, the main difference, whether it's plus or minus difference, we don't really care. So here we can say 1 and 3, the difference between them is 2. Next up, choosing the second smallest from both lists, we get 2.3, that's a difference of 1. The third smallest number from both lists is actually 3 from both lists, so it will be 0, a difference of 0, and so on and so forth. So you look at all these differences, and after parsing all of our inputs and having all of the differences, we want to add up the total differences, and the total distance will be our answers. So that was that. I'm going to show you walkthrough for the code which I wrote. Now the problem, I saw this in Go this year as a chance to learn Go, but I will be giving you a general walkthrough anyway. So let's first tackle the problem of parsing the input. Most of the cases it will be pretty much the same, so you don't have to think about it. But and you may have to look this up if you're new, but in whatever language you're using, look up how to open a file, read the lines from the file, and we will be getting something like part 2. Let's scroll down. Yeah, so we will be reading the input lines, and we will store the information from each two lines in a list. Like they told us that they had a list in the story, but I'm talking about the list as in the data structure or an array if you're using that. They're kind of the same. In Go, I'm using slices, so that's kind of the same. It's built on top of arrays, but you can really think of it as arrays. With that in place, we want to split the line with like 3 spaces. There are like 3 spaces, 1 2 3, 3 spaces. We want to split each line on these 2, and then I want to convert. That will give me the 3 and the 4 or whatever number there is on the both sides of the 3 spaces here, and we want to convert that to actual numbers. Now if you're using something like I don't know, Python do use the int function, whatever. I'm using Go. I use that strconf a to I, ASCII to integer, to take the values at 0, that's the left number, and append that to the list 1, the left list, and do the same thing with value 1 and append it to the right list. So by the end of it, you will have two lists. Now, how do we solve it? Now, the problem tells us that we need to somehow take the smallest from both the lists each at a time, like the first smallest, the second smallest, the third smallest, and so on. So I think it would be better if we actually sort the list ahead of time to and sort both the lists ahead of time, so that it will be, we can traverse the list just in a single iteration and add up everything, every difference of the elements in the list pointwise. So let's look at, so that's what I'm doing here. I sorted the list 1 and list 2, and then we can pass it on to problem 1, or P1 as I call it. Where is P1? This is the function P1. They should be of equal length, otherwise something like one line had a value and didn't have it on the other side. You may or may not check this. It is not really important. But we are going to do the thing that they said us. Pair up the smallest from the left to smallest on the right and find the difference. And and if you're doing a plain minus, that will not work, because notice 1 and 3. If I do 3 minus 1, it's 2. That is fine. But if I do 1 minus 3, that's going to be minus 2. And we don't want that. We want the absolute value of it. So it should be the absolute value of the difference. And you can do math.absolute or use any function. I'm just using a if statement to see which one to subtract from, which is the greater value to subtract from, and just adding on to the result. So in a for loop, you can write a similar for loop. Take the absolute value of the difference, or be sure to subtract the greater minus smaller in the correct order, and add all of these results to sum variable or result variable and return that. That will give us the first part of the answer. For the second part of the answer, let's look at the question. Typically on the second parts, if you're unfamiliar with Advent of Code again, you will be given like a small modification in the problem statement, which may or may not actually correspond to a small modification in your code. You might have to rewrite everything in your code because of the way you structured things in part 1 or something. But here they say that we were calculating differences, but now we are supposed to calculate a similarity score. And how to calculate the similarity score? We want to add up each number in the left list after multiplying it by the number of times it appears in the right list. Okay, let's see how that what that means. They mean that let's say 3 appears on the first number on the left list is 3, and let's look at the left list. 1, 2, 3. 3 appears on the right list 3 times. So we should multiply this left number 3 times 3, because it is the number of times where it occurs. Similarly, 4 will occur 1 time, and that gives us 4. 2 gives us 0, and so on. That's explained here. So we can do that. We can do a very naive way, and this is a very naive way of doing it. You take the list as it was, you pick every element, and for every element in the left list, you search up and count how many times it is equal. So it's 3 equals to 4. No, it's 3 equal to 3. Yes. You have a counter that goes up. It's 3 equal to 5. No, it's 3 equal to 3. Yes. You have another, the same counter go up. And you can do that for every element in the left list. You traverse all of the right list and get the result in that order, and that might actually work. It's gonna be it's not gonna be terribly slow, and it's a pretty easy problem. It's not gonna be that bad. However, let's return to our code. And let's see what we have done here. Remember, in our code, we actually first sorted the two lists. So the two lists are actually not in the way presented on the left right here, are in the way presented with in a sorted manner. What do I mean by a sorted manner is that we will be instead getting values like 1, 2, 3, 3, 3, and then 4. And from the right side, we'll be getting like 3, 3, 3, 4, 5, 9 in a sorted manner. So in ascending order. So what we can do is we can have like a two-pointer solution that traverses each of the lists simultaneously. And every time the left pointer, which is pointer 1, moves, we count up or move ahead pointer 2 in the list 2 to see if it matches until that element occurs. So for example, 3 occurs 3 times. For 1 3 standing at the left list, we will be advancing 3 times. Let's look at the code to make a bit more sense what I mean. Firstly, we don't want to overflow the length of the lists, that is the outer check. Now, what we want to do is something extra, and I will come back to it in a minute. So let's actually skip that. For what we want to do, is it here? Yes. So for every value in the I, we actually go ahead and what we want to do is keep a count of how many times 3 occurs. Um, whoop. In the second part, what we want to do is for every value in the left list, 3, we want to count up how much we have. And that is what we are doing over here. We are counting up how much pointer 2 has to move until the value matches from the list 2 to the current value in the left list. We add it to the count, we add it to the pointer, and we add it to the map. Why do we add it to a map? Why do I have a map right here? Let's take this actually. Why do we have a map right here? Well, you see, we just have a map. We just went through the last occurrence on the right list. So 3 to 3 were in the last 3 somewhere in the sorted list. But in my left list, I still have 2 more 3s to go. Should I do it again? Should I have something like backing solution? I don't think so. We already have counted how many 3s we have. So let's save that on a map, and every time if we encounter something which is in the map, so like that, if it is already in the map, so map in Go typically map values gets as 2 return values, the actual count if the value was present and whether the value was present or not is determined by this second return value, which I call OK. So if the value is OK, if we got something from the map, then we can say that it is valid even if it was 0, I don't care. Then we can save that multiplication, that similarity score into our result. Otherwise, we need to do this traversal again, right? This is to just stop us from repeating or figuring out some way to go back to where this block of 3 start or repeating characters start and do this. We don't want to do that. Once we are done, we know how much time it occurs. The next time we see that same digit, we can take it from the map. Now, what if this one thing happens? This one thing can occur, and this portion can occur if we have like a different um, like different values, like less than values. So over here you see, if we go in the straight time, we can see that we will be actually getting 1 first because our lists are sorted at this point in the program. 1, and 1 does not occur in my right list, and moreover, if I sort the right list, 1 will not even contain, the right list will not even contain any 1. So I need to account for that. I need to now advance the left pointer, that is pointer 1, to 2 and do the same check. If whatever we are pointing at the right list, that is pointer 2, is less than the whatever value we are pointing on the left list, which is 2, then we know we don't have anything because these are sorted. If the right value is already greater, then we will not even get anything to count for from the element in the left list. So we should just advance the left pointer instead. And then we finally reach to 3. And now we can do our whatever explained, that 333 in a sorted fashion, and save it in a map, and then do it. So here we go. We um, do one more 3 that is already in the map. We calculate that from the map. Essentially, we have a cache of values, and again we go 3 and okay, and then 4, and then we advance this pointer and so on. And at this point you will see that 4, and then we are stopping at 5 and 9 somehow. But at this point our outer loop, which was here, no, yeah, our outer loop that we should never go past length 2 will actually, that's the wrong loop, sorry, that our outer loop should be past the length 2, that actually fails. So we will not add anything, and we will add basically 0 into something. So at this point we can return the result. That's the code walkthrough. I think it's really, if you think, it's a two-pointed approach to how we are parsing the data, even if the data is presented in the sorted, in an unsorted form, which felt very good to sort because of the first part in the program, right? And instead of, I could start and do a n-square solution. Let's do some complexity analysis also. If I did, if I didn't do the sorting, this one would have, this is still linear because I will be, no, sorry, this will be mn operation, because for every value I need to search the next smallest and then somehow keep track of which one I did cover and did not, and so on. This will be on the order of n square, or mn. It's the same length, so on the order of n square. But if we sort it, we just have to do a linear scan and make the difference pointwise, so that reduces to a linear time complexity of n. With that linear time complexity, that does sound good, and but we are again tempted to do the scan, like the n square scan for every element in the left list. We need to count how many here are. That's a typical n square loop, like a nested loop. We and we already have a sorted list, and then we can just actually use our two-pointed technique back to actually advance the pointers until we get to the end of the block where like the 3 ends on the sorted list of the right, and so on and so forth. You can do this stuff, and eventually we'll calculate the similarity score, and then you add them all up, and then you can submit the puzzle answer, which will give you 2 stars. That was it. That was it for the problem for Advent of Code Day 1, and I hope you have a great day.